We'll just continue to do this. So you want to go ahead and find your derivative. Set your derivative equal to 0 and solve it. I'm going to make it easier here by dividing everything by 6. Does factor quite nicely. So we get a critical point of 2. You might wonder, why aren't we using the negative 1? Because negative 1 is not in our interval up here. We're only looking at numbers between 0 and 3. So then we need to go ahead and check all these critical points, our 2, and then our endpoints of 0 and 3. Plug in 2, plug in 0, plug in 3. Remember, when you're plugging them back in, to plug them into your original. So we get a negative 5, a 15, and a 6. Well, the smallest of these three numbers that we have here, the smallest would have to be your minimum. The largest would have to be your maximum. If we go ahead and take a look at the derivative, and if we look at our original function graph, and notice the blue graph over here is our original function, the red is our derivative. Whenever our blue graph is increasing here, for the x values that your blue graph is increasing, your red graph is positive above the axes. When your blue graph is decreasing, going down as you go to the right, the corresponding x values on the red, the derivative, are negative, meaning below the axes. Here we want to go ahead and find our extrema again on this closed interval. Happens to be a continuous function, just happens to be an absolute value graph. However, for the sake of going ahead and taking our derivative, we want to look at this as a piecewise function. Now, you should remember, if what's inside your absolute value is positive, and that's this here, if what's inside, and that only occurs for being positive when you're greater than 2, then it does nothing. So that's why we have this here when you're dealing with the inside of your absolute value being positive. Now remember, if we chose to use something that caused the inside to be negative, and well, that would have to be the other part of this, which would be numbers less than 2, would cause the inside of your absolute value to be negative, and remember that that does the opposite of what was on the inside. So then you want to just simplify this a little bit. The top simplifies down to 5 minus x when x is greater than or equal to 2. The bottom is a 1 plus x when x is less than 2. Then you want to go ahead and take your derivative. It's pretty easy to take the derivative of the top part. That's just negative 1. The bottom part is just 1. But keep in mind, we're dealing with an absolute value, and you have a cusp then at what causes your absolute value to be 0 is where it switches from one line to the other line. And when you have a cusp, your derivative is always undefined. So you'll notice there is no greater than or equal to 2 here when you're looking at your derivative. Because remember, your derivative never exists at a cusp. So then we'll go ahead and take a look at our critical points. So our critical points where our derivative is undefined, which is 2, and then we'll have to look at our endpoints. And so we'll go ahead and evaluate our function when x is 2. And we end up getting a 3. And you should realize that that is going to be a maximum, because our critical point of 2 is between our endpoints, and since we have a negative in front of your absolute value, that means it's a V shape going down, and we were at the top of our V. Well, you also need to find your minimum. Your minimum will therefore have to be at one of your endpoints. And so then you want to go ahead and evaluate each one of these. Plug in your 4, plug in your -5. Well, the smallest of these two, the 1 or the -4, would have to be your minimum. So your minimum occurs when x is -5 and the minimum value is -4. On this particular problem, we're still going to go ahead and find our max and mins on a closed interval following the same process. You want to find your derivative. On the one over here, you got to remember to do your chain rule. When you do your chain rule, derivative of your cosine is a negative sign, so that's why the sign in front switches. Then it would be the sine of your 2x times the derivative of the inside, which is a derivative of 2x. That's where this 2 comes from. Now we want to go ahead and solve this. Now we're going ahead and we're replacing this right here with your double angle sine formula. Your double angle sine formula, if you forgot, is 2 cosine x sine x. So now that I've done that, all I have to do is go ahead and pull out my common factor and then look at what's left. So then we can solve it by factoring. There was no common factor that would help us up here, so that wouldn't be helpful. So that's why we had to go ahead and use our double angle sine formula. You want to look at when is your cosine of x equal to 0? When is the other parenthesis equal to 0? Cosine is equal to 0 at the top of the circle and bottom of the circle because you're not left and right at all. We're not going to be concerned about doing any other revolutions because here we're going between 0 and 2 pi, so we're only looking for our answers between 0 and 2 pi, one revolution around. So then we also need to look at, okay, when is sine of x equal to -1/2? And you should remember that that is at 7 pi over 6 and 11 pi over 6. All four of these in red and in blue are our critical points along with our endpoints. All we have to do is go ahead and evaluate all of these critical points. So we go ahead and evaluate all these critical points. Remember, you got to plug them back into your original function. You plug 0 into your original function. Plug pi over 2 into your original function. Plug 7 pi over 6 into your original function. Plug 3 pi over 2 into your original function. 11 pi over 6 into your original, and your other endpoint of 2 pi into your original. You will then realize the largest of these that you get out, and remember we're only looking at the outputs here. The largest would have to be your maximum, so you know this is your maximum. You'll also realize that we have two of these that are the smallest. So we would say they're both our minimums. If we look at the graph for this, we would have the following graph. And you can see as you look here that you do have your two minimums right here at the bottom and your maximum. By the way, at 3 pi over 2, that would be referred to as a relative maximum, along with this endpoint, a relative maximum, because they're both higher than the points right next to them. This is a relative maximum, but it's your absolute maximum. And this is a relative minimum.